Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is all around using Millis as an interrupt-driven routine and interrupts. Let's just go to slide 4 and have a quick look at what we're doing. So Millis and interrupts. And interrupts, we're going to be controlling LEDs, but it could control anything, anything within the constraints. So I'm using this board here. Quick flick out of the camera. Let's do that in a minute. I'm using this board here. It's a PIC15 Plus demonstration board, extremely good. I'm going to use some LEDs, red block in the top there, and a switch. And I'm going to control the LEDs via the switch. Okay, so LEDs are connected for anyone not using this particular board through suitable resistors down to ground with the RB0 to RB3 signals. And also on this board, which is weird, RB0 is also the input for the switch. Go figure. Okay, really important. No VDDIO power, no domain IO. So let me just put some, I'm putting 3 volts into here, 3.3 volts into here, which gives me power domain across these green signals. However, yeah, I'm not using any, but I'm just making my point. So straight into Millis. Millis is a routine written by a gentleman called Chris Roper many years ago. And what it does, it enables you to do return milliseconds, the number of milliseconds since the program was started or reset. It's very much like the Arduino Millis function, but better because it's actually it's not inbuilt, you have to add it in, therefore you get more processing time. One of the issues with Arduino is Millis is running continually. I guess you could turn it off, but then other things would start to break as well because it's relying on that particular function. You can use Millis, you don't have to use Millis. Key benefits, it's non-blocking for multitasking. It sort of counts the milliseconds without halting your code. And it's unlike the delay function. It's non-blocking because with a wait, you've got it in a tight loop counting cycles, where this Millis is actually happening as an interrupt in the background. Now, to be very clear, it is a unsigned long integer, and therefore it goes up to 4.3 billion, and it's 1 millisecond precision via the timer in the microcontroller. So it's not a clock per se, it's a timer, so it will drift, and it's about 50 days before it overflows. And it always resets back to 0 when you do a power on cycle. So how do you include Millis? Let's walk the example in the code. Start up GC Studio and go to this folder that we're working on. I am going to select my folder. I've opened the local folder. It's in demos, vendor boards, microchip, PIC15 plus 2010 18F select the folder. And it will open it up automatically like that. It opened on my other screen. Back to the full desktop. So Control B or open up the Explorer. Millis 250 Millis. Control B to get rid of that little left-hand side. Let's have a look at the code. I'll zoom in. I've been doing other work, obviously. I have got the same header. I have got the 18F46Q35 selected, option explicit. Don't really need that, but it was there, so I'll leave it. All this header is exactly the same. Important thing in here, we're defining the LEDs as on those particular ports. They're constants. And down to this line here, everything else is just setting that board up. How do you do it? You include the library. It's hash include, less than and greater than, means go get it from the library. And the moment that you get it from the library, Millis is operational. What it does, it opens up a function that is called Millis, and it will return back to you the current milliseconds. What's actually happening in the background, every millisecond, a subroutine is being called, and it is incrementing the value that's stored within the Millis function. And so what we're saying here is put the Millis function in the result of that current milliseconds run, or the value of the current time effectively in milliseconds, into a variable called current milliseconds, CUR milliseconds. And then we're just doing some maths, okay, that says I want to flash an LED every 1000 milliseconds. I've set a constant. Let me just, I'd like that to be like that, uppercase. LED is I want to count 1,000 of these, so it's the current milliseconds versus some sort of variable that I've set up. So I've got the historical value of the last milliseconds. I've got the last milliseconds. I just do a quick bit of maths in here. If it's greater than 1,000, then I'm going to flash an LED. And then I store my current milliseconds in here. Now, I put it inside an int on, off, and on. Why? Because time might change. Is that important? Let me think. No, you don't need that. You don't need that. I don't think you do. I'll leave it in there just for clarity. But there's nothing else in here, because we're doing this calculation here saying if the current milliseconds less the last milliseconds, I didn't write this code, last, I'm just going to update that milliseconds. Let's just replace all those. Last milliseconds is greater than the LED rate, which means it's 1,000. Go flash the LED. Let's just go program it, see what happens. Function key F5. I'm going to start up my Gabtronics oscilloscope. Have I unplugged it? I might not have plugged it in since the last tutorial. Let me connect to it. There we go. Oh, we have a signal. So we have a signal. That's cool. Let's look at how the frame. Let's see what that is doing. It's doing something. I've got a 5-second division now on the oscilloscope. So let me put it back to 2 seconds. That's a 1-second division. And I've asked for 1,000 milliseconds, which is 1 millisecond. Okay, so is that 1 millisecond? That is 1 millisecond. Look at that, look. Now that's 1 millisecond. Perfect. That's pretty good demonstration. So what am I connected to? I'm connected to my Gabtronics oscilloscope and something else, which I'll show you. Quite cool. Let me just zoom out. I'm connected to this. Here is my oscilloscope up here. And you can see it just in the top of the screen here. It's actually, can you? That looks like a static picture to me. That was static. That watch isn't moving. This is the signal up here. You can just about make it out. There's an LED at the top. Let me just change the camera position. There we go. Look. Can you see the LEDs? No, I don't think you're ever going to see them. You're going to have to trust me. The LED is going on and off. I've also got my oscilloscope down here. To start my oscilloscope. Look at that, look. My watch is an oscilloscope too. Now, if you wanted to change the code here, and you wanted to have a different value, you would just change this constant here, and it would then flash. If I said 500, the same calculation. So you can have a massive code, do this little bit of mathematics in here to say what is get the current milliseconds, and then do some variable magic. You can do some great controls. Let's have a look what's happening on the oscilloscope. That's every half a second now. Great. That's my watch is getting more in scope. No, I can change the scale on that. Okay. Millis is extremely simple. You include the library, It exposes the function called milliseconds. You do what you like with it. Back to PowerPoint. Okay, interrupts. Let's just do the newbie thing on interrupts the way I learned it in the 1980s. The analogy is you're in the kitchen and you're washing the sink. As you're washing the sink, the front doorbell goes. You go answer the front doorbell, you resolve the answer with the postman, and you go back to the sink, carrying on washing up. When the doorbell rang with the postman, that's the same as an interrupt. The sink just stopped what it was doing. We went over, dealt with the postman, came back, that's the end of the interrupt, then we return back to washing up in the sink. It's a really simple analogy, and it works because the advantages are I was immediately responding to the postman, and it's efficient use of my time. So the advantages of interrupts are identical. You get immediate response to critical events, and it's efficient use of the resources. Now, to be very clear, it took me time to walk to the front door, and that's called latency. And you get the same problem inside of interrupts. You have latency until the event, a few cycles will occur, and you just need to be aware of that. You've got all types of interrupts, external interrupts like the postman, timer interrupts, peripherals can interrupt it, and software can do it as well. There are some key registers, and I've listed them: incom, pi, and per. And there is a special interrupt routine that you need to write, a special function that executes when the interrupt occurs. It's like the conversation at the doorstep with the postman. Keep it as short as possible and efficient, avoid delaying and going out to other operations. Keep it short. Set flags for your main code to deal with the problem. This microcontroller has 82 interrupts. I can only show 2. I can show you how DMA works. There's demonstrations on DMA, there's logic cells, I2C, it's all sorts. We've seen the serial working. We've seen some of the timers working, but this is it's longer list compared to the initial microcontrollers when they first came out. But any of these are available to you, and this is a full list. And so in here, what you get is a list, and you can see this in PIC18FxxQ35. You get what we call it in GCBASIC. So if I look at the one that we're going to look at, oh, here we go. I'll go back to my pen. We're going to look at external interrupt 0, and GCB will automatically set a flag for these 2 flags for you and manage those 2 flags. Just does it automatically. You start the process, and it says, right, I need to enable int 0. It will do it for you, and then when the event is finished, it will clear the flag. It happens fully automatically. So let's have a look at an external interrupt. It's a particular interrupt on a particular port. It's actually remappable via PPS. And what it detects the state of change of an external signal. So we're going to have a look at an interrupt service routine, and it will have automatically set the global interrupt for you. So where did I get int 0 from? I went to the data sheet, and I looked down this column called interrupt, and it's got int 0, and that is connected to RB0. Hence, that switch is attached to it on this board. And this is the whole of the code to make it work. I'm going to do it in here because it's easier. First thing I do is just make sure that when I push the button, the edge, the int 0 edge, EDG, is set to 0 because I want it to detect it in one direction. You can set it to 1, so when it rises, it's up to you how you do it. But that will detect the change. This sets up the handler. The next part is setting, where's my mouse gone? Clear. This sets up the handler. Interrupt, external interrupt 0, call the interrupt handler. You can call it what you like. some call it ISR, make it very hard. But if every time that interrupt happens, every time there's that goes down, goes to 0, it will call this routine down here. So what's going to happen in our little program is really simple. Clear. It's going to do a loop, flashing one LED, and it will only flash the other one when I push the button. Wait, why do we have? Look at that happening. Let me just go out to walk the code. We'll go out to the camera first, okay, and get the camera set up. Oh, look at the time. Look, time's. What is that clock doing? Let me activate it. There you go. It might have been deactivated, that one. So what I've got at the top here. Oh, look at all these cables here. That's the cable to the oscilloscope. RB3, here's the LEDs at the top, and I'm going to have to talk you through pushing the buttons at the bottom because I can't get it all on the screen at the same time. Into the IDE. Control B to open the window, or press the Explorer at the top left, using external interrupt to raise an event, 250. Ooh. I might rename that to 251, shall I? Let's just rename that to 251. I'm going to go rename that to 252. Shouldn't have the same numbers. 251, using interrupt to, and basically Control B to get rid of that. And it is the same code. The setup is identical. It's not. Oh, here it is. I've got it as 252 now. Never mind. We'll rename names. Same header setup. Here is the program. So when it goes low, it will call the interrupt. That's the enabler. This calls the interrupt itself, and here's the code. Flash the LED. So what we're expecting is LED 3 to flash, and only when I push the interrupt, the button, will it actually light the other LED. Let's have a look at the big camera. Go out there, and RB3 is flashing. It's flashing every 100 milliseconds because that's what's in the code. When I push the button, if I push the right button, there we go. RB2, look. As I push it, it's toggling it. Look, push, it came on. Push, it comes off. Push, on, push off. Now, how does that do that? Let's just make sure we look at the code. It's a not, so it's just toggling it, okay? It's toggling the LED. Let me just look, make sure that the PPS is, I misled you. I used PPS, look, I moved it to RA4, look, because I said it was PPS remappable. So I put the interrupt 0 on RA4. What's in here? Oh, look, that's in RA4. Here, and that's in 0 here, look. In 0 is sitting there, look. That's a little bit, that's okay. I'm happy with that. That explains why I had to push the other button on my board. That's correct. Now that still works because it's PPS doing the mapping. So what we expected, as we saw, LED 3 and LED 2. This was toggling every 100 milliseconds, and this toggles when I push the button. Okay, back to the big camera. It's just programming it. RB3 is flashing every millisecond, 100 milliseconds. Push the button, and RB2 goes off. Absolutely incredible, eh? What else can you do with interrupts? Well, you can use interrupts to control a motor. Let's look at that. This is essentially directly from the help. And this is something that was written years ago. So we've got a motor that we want to control, pulse it up and down. And effectively, like I'm saying, I've got a constant called motor, which is connected to LED 3. I've done that because my oscilloscope's attached to it. It initializes the motor control, and all it's going to do is increase the speed for over 2.5 seconds doing this. Look, it just puts the speed up and down by setting the motor speed. But that doesn't make any sense. How would the motor work? because all I'm doing there is setting a variable called motor speed. Because down here in the motor control, it's got an interrupt. On timer 0 overflow, call the PMW handler. And it's going to generate, yet again, another PMW signal for a motor control. I'm just saying to it, just use the defaults, look, okay? It's arbitrary. You just got to get the timer running. And in here, I'm saying, in my handler, if the motor controller is greater than my little PMW counter, set the motor on, else turn it off, and increment my little counter. Look at this. We look at this in here, in the oscilloscope. That's it, just programming it. It's another way of generating a PMW signal on any port by using a timer. Let me just change the no. So if you had a motor connected to that, you can set the motor to anything, and you can do that on any port. It's not PPS related, it's not port related, it's not one of the standard commands, but it's a motor control. So what I'm doing there is just bringing the motor up and down. Look, here we go, look. That should be step -1. Let's have a look at that again. Up, full on. Oh, that's better code, look at that. Full up, full down. So that would be a motor controller. Using interrupt, timer 0 interrupt. Notice how little code there is in here. It says on interrupt. That means that all the code with respect to setting up the interrupt has been set for you, including setting up the global interrupt handlers. When you call this PMW handler down here, it's clearing the flags on the way out. There's no resetting of the flags here. That's done automatically. There may be cases where you need to set a flag, but in the general case, you don't have to. And all I'm doing is starting the timer. So every time that the timer overflows, it calls my PMW handler, which gives me a motor controller. Good. Big subject. Back to PowerPoint. Using storage. All the memory, got loads of memory. How do we use it? That's the next tutorial. So that was end of this tutorial. Enjoy.